Hello. So today we're going to continue just reading Pandas documentation, and we are going to try to replicate one of the core elements. For the moment, we're going to ignore date ranges and stuff like that, and just focus on creating a basic data frame and see how far we can actually get with something very basic. Again, this is not meant to be super fast or the most algorithmic efficient way of doing this. It's just a way that we are studying how we can manipulate data in Python to accomplish this. So I start again with a test. So we're going to have a list of records that have a name and an age. So this is a string and this is an integer, and let's see how far we get. So if I run the test right now, it's going to break because there's not even the class here. So we open the frame file, and let's just, of course, we're going to need the series object that we previously created in the last video. So from bamboo, import series .series, import series. And now we create our class DataFrame. Now our class is not going to take anything other than just the original data, which has to be a list. And yeah, maybe we should start doing some type hints. So let's just make the original data part of the data here, part of the class here, and then let's make a function that actually creates a data frame, and let's call it this. So of data frame, it's going to be this. So let's get to see into working on what the make df should do. It doesn't take anything because it's not going to it's part of the self, but it does return something. It's going to return, I believe, just a dictionary in which every key is the name of the column and every value is a series of what we created here. So let's see. First, we need the column names. The column names are pretty easy to get. Column names, it's going to be equal to the self.data. And after we do this, we have to keep track of the records, and for every possible column we need an empty list. So that's pretty easy to get. So let's create just an empty list for every let's create an empty list for every one of the key values here, of the keys in every record. So this is going to be a list for length in range of length of the column names. So because the column names are 2, now we have an empty list of 2. And now that we have that with a set length, let's loop through actually the records and just try to get the values in a columnar format, so that we are going to summarize, and we have John, Jane, and Joe in one of the columns, and we have 23, 25, and 21 in the other. So let's do that. So for record in self.data, now we are here in this example. So first of all, if the column names don't match the column names that we have here, we should raise an exception, because by definition we need to have the same number of elements in all of them. So if column names is different from record dot keys, then that means they're different, and we're going to just raise exception. Column names need to be the same for all the records. If not, it means that we can just keep adding the records into our list. So how do we do that? Because this is actually going to have an empty list, we're just going to push every one of the values here. So let's do now for value in records, in record, let's push, actually we need to keep count of this so that we know the index. So let's use enumerate for I value in enumerate records of I, it's going to be appended with the value. And so that is guaranteeing that every value in this column will have only, in this case, John and then the age. So let's see how far we are here. Let's put an IPDB here and let's run the test. So we should have something with a little bit more value now. Okay, DataFrame takes no arguments. So let's see, DataFrame takes data, definitely. Then where is this failing? In line 10. Oh, I think we have a double underscore here. Yeah. Okay, so where are we? Yeah, so it's not working. List has no attribute. Keys. Of course, so we need to make this for the first record only, which is a dictionary. See, okay, so we are here and we should have records, which should be now a list. Oh, but we're only appending for some reason the name of the columns when we should be appending the value. So let's see what happened. What's the last record? The last record is this. We compare the keys, and then for each of the records, enumerate record dot value. I believe these should work. So let's see. So now the records actually have John, Jane, and Joe, and 23, 25, and 21, which is what we were expecting. So now that we know that this is working, we need to create a series for every one of them. And what we had thought in the beginning was that we were going to return a dictionary with the column names being a key, and then every value is going to be one of the series that we have previously created in the last video here. So let's do that. So now we need to create the data frame. It's going to be just a dictionary. And now for every one of the column names, we need, for each one of the column names, we need to append these. One of the problems is, but we have a problem here. This is not a list with the column names. This is a dictionary type of object. What I mean is that if you have something like this and you do dot keys, this is not a list. So we need to convert it here so that we can actually do this and access the name of the keys. You can simply not do this here because it's not subscribable. So to solve for that, we're going to first turn the column names into just a list. And now for I and column record in, and let's enumerate the records, we can start adding the column names. In this case, the first, it's going to be name, and the second one is going to be age, and that is also going to be reflected here. So now we can do df of column names of the index I, it's going to be equal to the column record. Well, but actually this is a series object. Now we can just return the data frame. So now when we do this, we should have a series object in all of them. So let's change, let's try to take this for a ride here. So let's import it and create this. So now what's df? df is a data frame. Actually, it's not a very good name, so let's, because internally it has a df, but let's see. So correctly, df is a dictionary now, but if we do this, it should be a series. So if we do this, it's already a series, and let's see how the age looks like. Awesome. So we can see that we're getting very close to this format. We are only in this. What's interesting, we didn't add some functionality here, but we can quickly make something that I think is very useful. So for example, we can start doing operations here, and let's add. So how would we add all these values? How we can add that functionality? So we know that once everything is instantiated here, so we can just return the sum of self.values here. If we run it again, like this, nothing broke, so that's good. Let's test the age, and let's do .add, and we something valuable. So what happens if we do the same for name? So that's not going to work because this is not supported, but we are slowly but surely increasing the capabilities of this. So tomorrow maybe we will be adding how do we do the repro for this, because in the previous video we saw how we created this format, which is working pretty nicely, but we still don't have the ability to see the whole data frame in one smooth print. We are only capable of doing that in multiple, one series at a time. Thanks.